event. Uh, he is the Director of Data Science and Generative AI at Cityscape, Dr. Syed Hassan Amin. Please welcome.
Assalamualaikum. How are you guys? Can you hear me, guys? Okay. Okay. So, as you know, my name is Dr. Hassan, and I have been working in and around data science for last 20 years since my bachelor's days. So, one of the few guys who learned a bit of NLP back there in 1999. So, एक प्रोफेसर साहब थे हमारे, वो हमें NLP पढ़ाने की बड़ी कोशिश करते थे. Everybody hated him. Okay? And he was totally, जिसको कहते हैं ना, mad about that, you know. उसने बस NLP ही पढ़ानी होती थी किसी भी तरीके से किसी भी लेक्चर में. So yeah, we did learn NLP back there. So let me introduce you to the topic. Basically, we are looking into future, harnessing the potential of LLMs. Okay? So it is a bit about past, but a lot more about future, how things are turning out for us. So that's really important for us to understand. So I will give you a bit of introduction, then obviously all the advancements that we are seeing. And I will like to introduce one of the applications, Riga, that we developed recently in last 3-4 months, should I say, and how that leads to the artificial general intelligence that probably we fear so much. Okay. LLMs are large language models like GPT-3, GPT-4, Llama, and all the other models. We typically tend to look at them as just, you know, generating text, or if they are diffusion models, then generating images. But I don't look at them as just, you know, models that can predict the next word or next sentence and all that. So I'm looking at them as more like machines that encode knowledge. And knowledge is the oil of the economy, right? So LLMs, to me, are turning out to be oracles that have all the information, they have encoded all the information, and they can intelligently answer most of the questions. So we can say, okay, we do have challenges like hallucination, creating false information, incorrect facts, and so on. So we do have those information. There are models that are pretty good at creating correct outputs most of the time. There are models that, like BARD, that might go horribly wrong as well. So I think even with humans, you know, even myself, everybody, Umar, you know, at times we will totally go in the wrong direction. Okay, we might misrecall, or maybe, you know, just give totally incorrect facts as well, you know. So this thing happens, and this is happening with our oracles or LLMs as well. So one of the things that we need to learn is, you know, these models, they are encoding information and they are able to answer information as well. So when I look at them, what I see is, you know, in terms of creativity, most of the time what we are doing is we are connecting the dots. Okay, so usually the creative process is that you try to collect all the information, you try to uncover most of the facts in a given area, and then you're trying to connect them. So LLMs, because they are able to encode all the information, and they have shown that they are pretty good at connecting the dots as well. So I think they are already creative. And we are only learning how to best use their creativity. So given that they are creative, and we can see that they are creative in various ways, from writing us emails to writing us essays to answering our questions, you know, LLMs are going to drive the economy as well, because it's a knowledge-driven economy. So LLMs are engines that are going to drive our economy and everything else, you know. So obviously we are dealing with that. Okay, so if you, in a formal way, if you define an LLM, so it's an algorithm that uses deep learning techniques, and you fed it all the data, all the information that you have got, and then it can do certain things like generating text, summarizing information, predicting new text, and so on. And that's a formal definition, but it obviously misses on the key idea or key result conclusion that we see is, these things are able to generate information. They are generating new content and so on. And one of the things that obviously we see is, these models are growing at a pace of 10x. So in terms of the size, we might think that, okay, by increasing the size of these models, we might have more powerful models. We must understand that we are still at a very early stage of this journey. So, because I have been associated with that, I know that back in 2003, I was trying to create a neural network, a deep neural network. Even at that time, the idea was firmly there that if I can somehow train a bigger network, then I would get better results. That was the whole idea of my paper, and obviously I was using 386, 486 at that time, there was limit to what I could do. So my training was running for 5 days on those 386, 486, and then maybe I was able to do those experiments for maybe 200 images, and I did an OCR on that, but that idea was there. The thing that was not there was, can we train those models to a level where actually they can probably, they can be as good as human vision. So we did not know if that was really possible, but we were seeing at that time, like 20 years ago, I was able to see that, if I moved from 2 layers to 3 layers, from maybe 100 nodes to 200 nodes, then my results were improving. So those ideas were already there. But obviously, we were not sufficiently there in terms of technology or investment to kind of create the results that we see today. There are lots of applications, from coding to natural language understanding to translation to summarization and so on. But this is not all. The bigger applications are, your virtual doctor, your clinical decision support, your virtual real estate agent, your virtual liar, and so on. Completely intelligent beings that can, help you, that can fight your case, that can probably advise you on how a certain problem can be solved. And so even, cutting edge labs, I can imagine today that cutting edge labs, they are in Stanford, MIT, Imperial, Cambridge, they should be or would already be putting all their research papers and relevant knowledge into an LLM and trying to get answers from them. So your research scientists may also be virtual, but it's not like replacing us. It's like, from very early days, what the word oracle, that's probably thousands of years ago coming, from the Greek mythology and all the Greek literature. So we always needed oracles. We always needed teachers. And we needed that confidence. Okay, we need someone who could answer our questions in a logical, rational way. And most of us, never have that, so LLMs are going to be your oracle, your mentor, your assistant in every field that you work. And, you would be lucky if your organization or your environment is giving you access to really specialized LLM, and you have an edge over others. Okay, so what makes LLM special? ठीक है, exactly यही point from the very beginning of my conversation I'm trying to make. What makes LLM special is not the generative abilities. It's the ability, to encode knowledge, to connect the dots, and to be able to intelligently answer your questions. That's the most important thing. And there are companies like Bloomberg, they created a large language model, to basically for finance, helping their clients to answer all the queries that they might have in an intelligent manner. ठीक है कि कैसे information impact कर रही है उनके financial decisions को, ठीक है? And similar thing definitely should happen in all the other fields. So secretly, I believe most of the corporates are building their own LLMs. ठीक है, क्योंकि उन सबको एक AI advisor चाहिए, ठीक है, जो सारी information को encode करे, connect करे, and then if you ask any question, then it's able to answer that with the help of that information, which otherwise, would be lost, or maybe you're not able to answer it in a proper way without a lot of effort. ठीक है, so why everyone needs their own large language model? ठीक है, so अब अगर मैं large language model कहूँ, तो you should read their own AI. ठीक है, so that's what it is. It's not large language model, it's your own AI. ठीक है, so हर बड़ी corporate or even छोटी भी, to maintain an edge, you need your own AI that should be powerful enough so that you can compete in the world. So data privacy is one of the concerns. Usually हमने सोचा था कि यार जब ये चैट जीपीटी और इस तरह की चीजें आएंगी तो लोग उसके साथ डेटा अपना शेयर करना चाहेंगे, ठीक है, but that's there is incredible amount of resistance to that. इसलिए कि अब हम अपनी वो गूगल वाली क्यूरीज नहीं शेयर कर रहे, ठीक है ना, हम उससे क्वेश्चंस पूछ रहे हैं, the questions that lie at the heart of our competitiveness, our business secrets, so, and to answer those questions, in many cases, you need your proprietary data and information as well. ठीक है? So you don't want to do that. So data privacy is one of the concerns. But the other concern, and I think more profound, more important concern is, your competitiveness. You want to improve your customer service, you want to decrease your costs, you want to solve problems faster than others, and you want to enable knowledge sharing across your organization. For all these reasons, you need to encode all the information that you have got in a more effective manner in your own AI, and use that, दूसरों के पास उसकी access नहीं होनी चाहिए. And I think it's not the, artificial intelligence or artificial general intelligence part that is more dangerous. The most dangerous part in this whole game is somebody else having an AI that is more powerful than yours, and they are hiding it for their own profit. So ये जो human greed element है ना, इसमें सबसे ज़्यादा dangerous part वही है. If somebody has 10 times more powerful AI than yours, then obviously you are out of the business. Then it becomes the existential threat जिसको हम कहते हैं ना, फिर वो बनती है, ठीक है? So LLM advancements, obviously we have too many large language models being launched, and I think it's, in a way, it's lucky, because first large language models like GPT-3 especially, and then GPT-4, they took like $100 million to $200 million for training them. और उनका overall अगर आप budget देखें तो maybe $1 billion to train GPT-3, ठीक है, $10 billion की Microsoft की investment है, ठीक है, but obviously Facebook shared Llama, and since then, other people have come up with different approaches to train their own models, ठीक है. So there are different approaches, like some people came up like Alpaca at MIT. What they did is they created a few thousand instructions using ChatGPT, and then they retrained Llama with that. And Llama might have taken a couple of millions of dollars by Facebook, but Alpaca, they were able to train it like with $600. You can do that. ठीक है, हो सकता है उनके ज्यादा लगे, $10,000-20,000 लग गए हों, ठीक है, but they claim that you can retrain Alpaca with a small data set, let's say 15,000 instruction, maybe more. तो वो आप उसको retrain कर सकते हैं. So initially, our first impression was that if you have more parameters in a model, it's gonna be better. ठीक है, तो आपके पास बड़े-बड़े models हैं, Palm है, Bloom है, MT-NLG है, ठीक है, all very big models. GPT-3, by the way, is smaller than most of these models. So, but GPT-3 is performing better. So we already have established that, bigger may not be better in this race for large language models or in this AI race. The other thing that is going to matter is obviously your LLM architecture. Okay? Most obviously, I would say all of them are transformer architecture primarily, but we are obviously, the main threshold was, ठीक है, ये हमें पता है कि यार हम बड़ा नेटवर्क बनाएंगे डीप लर्निंग का तो वो बेटर होगा दूसरे से, ठीक है, हमें 20 साल से पता है, मुझे पता था ये, ठीक है. सो आई कैन गेस कि अमेरिका में दूसरी जगहों पे पीपल न्यू दिस थिंग ऑलरेडी. So the main thing that is going to differentiate is your algorithm, your approach, ठीक है, आप उसको कैसे लेके चल रहे हैं, your architecture for that model. Maybe that is, you come up with a different attention mechanism, and that attention mechanism will be really good for certain kind of problems. Already हमें पता है, ठीक है, typical सी चीज है, ठीक है, आप लोगों ने भी अगर basic neural networks बनाए हैं तो by adding more layers, you can come up, in many cases you can have better results. And maybe a different architecture or maybe a hybrid architecture, convolutional neural network को RNN के साथ combine कर दिया, कुछ कर लिया, ठीक है, maybe you can have better results as well. So transformer architecture obviously is at the heart of this revolution, ठीक है. So you have an encoder part in it, जो कि जिसको आप information feed करते हैं by converting your input to embeddings, ठीक है. Embeddings obviously काफी advanced हो चुकी हैं. They are able to encode much richer information, and then obviously you apply multi-headed attention mechanism on that, ठीक है, ताकि words आपस में connect हो जाएं. You feed that to decoder part, which again uses multi-headed attention and a feed-forward network to generate the output for you. Pretty complex architecture with lots of layers. So this is, a focus on that. So encoder is, your prompt or your input, whatever that might be text, might be image, might be something else. That goes, into your encoder, ठीक है, the embeddings that we create and the attention mechanisms, multi-headed attentions that we apply onto that, that basically gives us the contextual information. कौन सा word किसके साथ connected है, ठीक है, that goes to your decoder. Input output आपस में कैसे connected है, कौन सी input कौन सी output के साथ strongly connected है, and then obviously a decision mechanism, a deep neural network to produce the output. So decoder basically does the connection with the output and so on. So I mean, you can say, okay, this is all probability. If this is the word, ultimately, that word would be generated. Okay. So I was talking about different types of architectures. So here we have three main types of architectures. So encoder only models. BERT was your encoder only model. Then BARD and T5 are your encoder decoder models. And your GPT-3 is based on the decoder only model. So with GPT-3, they demonstrated that if you have a decoder model that is large enough, and if you feed it enough data, then it can give you basically all those fantastic results in terms of text generation, and translation and all the abilities that it has, even leading to your artificial general intelligence. One of the things, obviously, initially, getting it done was the biggest thing, right? And it obviously was very costly. ठीक है? ये realize करने के लिए कि we can achieve these kind of capabilities leading to a level of AGI, our initial level of AGI, it has been very costly. ठीक है? Maybe tens of billions of dollars. So GPT-4, a multimodal model with maybe 175 billion or more parameters, one cycle of it takes $100 million to $200 million to train that. And they are using, these 10,800 GPUs for 11 months. Really long period of time to do this training and so on. So just the initial model thing, maybe it took, according to some estimates, maybe more than $1 billion to achieve that model. But now that it has been achieved, it's time to optimize that in terms of the cost, in terms of the performance as well. Achieve better performance with lesser cost, and so on. Google Bard, obviously, they might have spent even more money on that. Their architecture is probably a lot more complex than OpenAI architecture. And OpenAI maybe was lucky in the sense that they may have learned a lot from what was going on at Google, and that would have given them some opportunity to improve it. So Microsoft invested $10 billion in OpenAI, but they are better off in terms of what they have got in terms of the return. So the cost challenge is really the big one. The challenge that people are now solving is obviously overcoming the cost and improving the performance. And people are doing incredible work at that. In just a few months since Llama was released, we have seen, and obviously Falcon has been released. So Falcon's main claim is that using high quality data, because we can see that GPT-3 was using pretty low quality data. I mean, they could not remove initially the duplicates, false information, and all the other cleaning issues, So Falcon basically used a high quality data set and, improved certain algorithms, and from, they have probably improved the cost part by at least 10x. तो उनकी cost reduction जो है at least 10x उन्होंने cost reduction जो है उसमें achieve किया while achieving similar or better performance. Then another approach which has come up is, if you have access to, and there are lots of open source models, so if you have access to them, then you can basically create instructions for a specific domain. Like, for example, if I'm going to do it, then probably if I'm working for real estate, I will create an instruction set for real estate and use that to create an existing open source model. And that would give me better performance than GPT-3, GPT-4 using my own model. Okay, so everybody now can do that kind of thing. So we have seen algorithms like LoRa and QLoRa, which are allowing people to train their models on basically even consumer GPUs or pretty low-end GPUs. ठीक है? So overcoming the cost challenge, $1 billion तो probably बड़े थोड़े VCs होंगे जो आपको देंगे, ठीक है ना? उसके लिए आपको माइक्रोसॉफ्ट ही ढूंढना पड़ेगा कि वो आपको $1 billion भी दे, साथ में सुपर कंप्यूटर्स भी दे, ठीक है, और आप उस पर ट्रेनिंग करें. लेकिन obviously most of the data centers and there are lots of them have pretty good GPUs which can be used, and people are using them to train their own large language models. ठीक है? So that is now becoming possible. So Alpaca model basically demonstrated that, given certain domain, you can create instructions and train any open source are a suitable open source large language model on top of that, and that will give you your own AI for a cost of maybe $600. चले आप इसको $60,000 भी कर लेना, and you create your own AI for a certain domain, then that would be worth it. ठीक है? That's not a big thing. Fancl model again demonstrated that, you can basically, if you have high quality data, and in most of the corporate world, banks, insurance companies, e-commerce companies, you have lots of high quality data, product prices to customer conversational data and all that. You can use that to create your own powerful AI that can probably do manage your sales, answer customer queries and so on in your own domain. ठीक है, वो फिर गलत नहीं होगी क्योंकि उसको पता होगा कि आपके एसीज कैसे ठीक होते हैं and so on. So customizing LLMs. So we already know there are two approaches that we use to customize LLMs. Fine tuning is primary. I would say customizing is primarily done with fine tuning. In fine tuning, you are actually, taking an existing LLM and then retraining it, maybe one layer or maybe more than one layers. And then it basically, so let's say somebody gives you Falcon model or Llama model, and you have your own domain, maybe insurance, maybe health, maybe education. So you take your data, organize it according to how it's going to work for you for that model, and then basically you train on that. ठीक है, तो आपका अपना एक फाइन ट्यून मॉडल बन जाएगा because it knows your domain. ठीक है ना, आपने couple of GBs या TBs का डेटा उसको फीड किया है, ठीक है, then it will answer all the questions correctly for your own specific domain. Prompt engineering, everybody knows कि आपको बताना पड़ता है कि भाई from a simple prompt जो कि question होता है to role based prompts जिसमें कि आप कहते हैं okay, you are a real estate agent, you are insurance agent, you are a doctor, and you are going to guide me about this and that. ठीक है, so prompt engineering obviously on the fly होते हैं, primarily obviously low cost है, fine tuning initially high cost है, लेकिन अगर आपका sufficient usage है, ठीक है, तो फिर जो है फाइन ट्यूनिंग आपको लो कॉस्ट पड़ेगी. ठीक है, सो फाइन ट्यूनिंग का एडवांटेज होता है कि सारा डेटा, सारी इंफॉर्मेशन आपके मॉडल के पास ऑलरेडी है. सो आपने उसको लेट्स से 10 पेजेस का प्रीफेस नहीं देना कि यार ये इंफॉर्मेशन लो और फिर मुझे इस चीज का आंसर दो. नो, यू डोंट नीड टू गिव इट ऑल दैट इंफॉर्मेशन. It will already have that information. You can just ask the question directly. So here is simple prompt. You can say, okay, give me recipe of this, and then it will be able to answer you. And nowadays, one of the things that is happening, and we have that in our product, is proactive communication. It would even come up with relevant questions. ठीक है, जो कि फर्दर आप कन्वर्सेशन को ड्राइव कर सकते हैं. ठीक है, रोल बेस्ड प्रॉम्प्ट की एग्जांपल ये है कि यू वुड टेल इट कि आप ट्रेवल गाइड हो. ठीक है, सो फॉर एग्जांपल आप उसको कहेंगे आई वांट यू टू एक्ट एज ए ट्रेवल एजेंट, आई विल प्रोवाइड यू माय लोकेशन एंड यू विल सजेस्ट प्लेसेस टू विजिट. ठीक है, तो आप उसको एक रोल सजेस्ट करेंगे और आपका जो लार्ज लैंग्वेज मॉडल होगा वो उस रोल के मुताबिक अपने रिस्पांस जो है वो क्यूरेट करेगा. सो फाइन ट्यूनिंग वर्सेस प्रॉम्प्ट इंजीनियरिंग. सो डिफरेंट अप्रोचेस. ऑब्वियसली फाइन ट्यूनिंग के लिए आपको रिफाइंड डेटा चाहिए, मे बी वो लेबल्ड होगा. ठीक है, लार्ज सेट ऑफ एग्जांपल्स आपको चाहिए और ट्रेनिंग कॉस्ट उसकी हाई होगी. लेकिन एज आई सेड, इफ यू हैव सफिशिएंट यूजेज ऑफ दैट मॉडल एंड इफ दैट मॉडल इज रियली इंपॉर्टेंट फॉर यू, ठीक है, देन फाइन ट्यूनिंग मे बी अगर इवन $30,000 $40,000 आपके लग भी जाते हैं इवन GPT-3 जैसे मॉडल को ट्रेन करने के लिए, then that's okay. Because it will give you sufficient rich intelligence and correct responses for your domain. ठीक है, then you can rely on that model. ठीक है ना, आप कहें कि यार अब मैं जा रहा हूँ हवा में उड़ के, तो I can bet my life on that. So prompt engineering is obviously very low cost. आपने कोई ट्रेनिंग नहीं की, आप सिर्फ मॉडल को गाइड कर रहे हैं. ठीक है, लेकिन इट कैन बी इनकरेक्ट, क्योंकि आपने अपना डेटा उसको नहीं फीड किया. अगर आप डेटा फीड करने की कोशिश करते हैं देन ऑब्वियसली आपके नंबर ऑफ टोकन ज्यादा हो जाते हैं. ठीक है, विद इंक्रीज इन नंबर ऑफ टोकन the cost, the processing cost, and obviously the cost that you are going to pay is going to increase. So obviously अगर आप प्रॉम्प्ट इंजीनियरिंग अप्रोच के साथ जाते हैं तो बड़ी सेंसिटिव है कि एक ही क्वेश्चन आपने जरा सा मुख्तलिफ तरीके से पूछ लिया तो उस मॉडल का बैकग्राउंड आपकी डोमेन में नहीं है. ठीक है, वो मॉडल जो है वो आपको इनकरेक्ट आंसर दे सकता है. फाइन ट्यूनिंग में बिकॉज यू हैव फेड ऑल द डेटा कन्वर्सेशन जितनी भी इंफॉर्मेशन है रेलेवेंट टू द डोमेन वो आपने ऑलरेडी उसको दी हुई है. मॉडल को आपने ट्रेन किया हुआ है. इट्स वेट्स हैव बीन updated according to the intelligence that you have and you need in your organization. So obviously from the performance perspective related to task, it's going to be very high performing. It's going to be low cost per question. So अगर आप lots of question पूछेंगे तो वो obviously आपके लिए cost घट जाएगी. More robust to nice in the data. ठीक है, and so on. Initially uski obviously you have to prepare the data set, you have to do the training, so initial cost uski zyada hogi. theek hai. So looking at LLM applications, so one of the applications that we came up in last 6 months was Riga. So on Riga we really got started from the idea back in January. ठीक है, सो जनवरी में हमने उसकी बात करना शुरू की एंड देन फेब मार्च में हमने उसमें एक्चुअल डेवलपमेंट शुरू की. ठीक है, सो रीगा इज बेसिकली अ प्योरली कन्वर्सेशनल रियल एस्टेट चैटबॉट. चैट जीपीटी स्टाइल का उसका यूआई है. ठीक है, एंड इट एक्ट्स एज ए रियल एस्टेट एजेंट और रियल एस्टेट असिस्टेंट फॉर यू एंड इट कैन आंसर ऑल सॉर्ट ऑफ रियल एस्टेट क्वेश्चंस फॉर कैनेडियन मार्केट. ठीक है, सो कैनेडियन मार्केट का डेटा उसमें है. सो बेसिकली इट बिकॉज आई वर्क फॉर अ रियल एस्टेट ब्रोकरेज. ठीक है, सो वी हैव देयर रियल टाइम डेटा which we feed to this Riga, and it is able to answer questions as per data fed to it for last 24 hours. So then obviously आपको कोई ऐसा फिल्टर्स की जरूरत नहीं है. You just talking to a person, so you can ask what is the current listing price of this, how many bedroom does it have. So ये देखिए कॉन्टेक्स्ट भी एस्टेब्लिश कर रहा है. ठीक है, एंड अब कोई भी आप रियल एस्टेट लिस्टिंग साइट्स पे गए होंगे, आप उस रियल एस्टेट लिस्टिंग साइट से आप ये नहीं पूछ सकते कि यार ये घर में लेना चाहता हूँ, इसके करीब अच्छे स्कूल कौन से हैं, हॉस्पिटल्स कौन से हैं, ऑल दोस थिंग्स दैट यू हैव that your property buying or renting decision is based on. ठीक है, वो सारे questions आप इससे पूछ सकते हैं and it is able to answer all those questions. So this is the UI. So we have basic prompts for it. Then you can have conversation with it in your own words, like can you show me some 2-bedroom homes, etc. and then can you give me details. तो वो आपको फिर उसके मुताबिक कन्वर्सेशनल वे में पूरा रिस्पांस बना के देता है. सो डेटा इज रियल टाइम, इट इज कमिंग फ्रॉम आवर डेटाबेसेस. ऑब्वियसली द रिस्पांस इज बीइंग क्यूरेटेड बाय GPT-4. फिर वो कन्वर्सेशन आप जारी रख सकते हैं. ठीक है ना, फिर आपने नेक्स्ट फॉलो अप क्वेश्चन पूछा, कैन यू फाइंड अफोर्डेबल हाउसेज विद वाटर फ्रंट. अब एक लिस्टिंग साइट से आप ये नहीं पूछ सकते कि यार वाटर फ्रंट वाले घर मुझे दिखा दो. ठीक है, तो वो आपको बताएगा, फिर आप कहेंगे can you provide details and so on. So it's it gives you much more information than probably a real estate agent, a real world real estate agent would be able to give you. Okay, because it has all the data, all the information, and by the way it's not yet fine tuned. Okay, up at a point in time when we are able to fine tune it, okay, then probably these results will be much more richer in the sense, because then it would have the deep understanding of the real estate domain. कि real estate domain में लोग किस तरह बातचीत करते हैं, किस तरह के questions पूछते हैं, क्या इंफॉर्मेशन, उसके पास सारे घरों की इंफॉर्मेशन होगी, सबकी डिस्क्रिप्शंस होगी, सारी लिस्टिंग की, सारी कन्वर्सेशंस होंगी. ठीक है, जब उस पे वो ट्रेन होके आएगा, obviously I don't know how good that would be. So what we are seeing is already, a high level of intelligence. ठीक है? Maybe AGI की definition पूरी होती होगी, maybe नहीं होती होगी, maybe कुछ benchmark satisfy होते होंगे, maybe नहीं होते होंगे. ठीक है? But AGI refers to hypothetical form of artificial intelligence that would be capable of performing any intellectual task that a human can do. ठीक है? अब human जितना generalize करना probably necessary भी नहीं होगा. ठीक है? So what we need, we might need multiple models to achieve that. ठीक है? लेकिन ये है कि for any given domain, you can create a very highly intelligent AI for that domain. And that would obviously surpass the capabilities of humans in that domain. ठीक है? So AGI would have a broad range of cognitive abilities and be able to reason, learn, and solve problems in a way that is comparable to human intelligence. So that is something that we probably are already seeing that. ठीक है? अभी जो मॉडल होगा वो कल परसों जाके आज के मॉडल से सीख के ज्यादा सुपीरियर होगा एंड सो ऑन. सो लर्निंग जो है वो तो इटरेटिवली ये मॉडल्स कर रहे हैं. एज वी कन्वर्स विद देम, एज वी फीड देम मोर डेटा, एज वी फीड देम मोर कन्वर्सेशन. और ये चीज तो जिसको कहना चाहिए रिसर्च से प्रूव भी हो गई है कि इफ वी आर एबल टू गिव इंस्ट्रक्शंस टू अ मॉडल, then it can perform better than the original model. ठीक है? So we are iteratively making better and better models, more and more intelligent models. And let's not be afraid. They are there to help us. ठीक है? हमने उनको ड्राइव करना है, उन्होंने हमें सर्व करना है. ठीक है? And that's how it works. So AGI would be able to apply its intelligence to a wide range of tasks, from scientific research and engineering to creative endeavors such as art and music. In the beginning of my talk, I said, I can imagine that most of the research labs out there, NASA and everybody else, they would be building their own models. They will be feeding them all the information that they have, and they would be trying to get answers to cutting edge questions. And some of those answers might just be the next big innovation that we see somebody, a real world scientist, might be claiming as his own. ठीक है? वो उसकी होगी नहीं, वो actually LLM ने generate की होगी, and then obviously humans would have authenticated that. ठीक है? उसको उन्होंने verify किया होगा and so on. लेकिन ये है कि the pace of innovation वो बहुत ज्यादा हो जाएगा, because some questions and some answers that might take us decades to get there, we might just get them. Okay? And then all we have to do is to do the verification. And I think that's our role today. Okay? कि हम boldly in models को, in technologies को approach करें, and then, ask them all the questions we have, look at the answers that you are getting in a very critical way, and try to get to that point where you probably, your fear, your hesitancy is not letting you get there. Probably these tools are going to help you get there much quicker than we probably can do. So thank you very much.